Hello students. So next question is the decomposition of hydrocarbon follows the equation this calculate EA. So this is given in the form of Arrhenius equation and we have to calculate energy of activation. So how to proceed this? First we will write the Arrhenius equation, that is K is equal to AE minus EA by RT. So this is our Arrhenius equation and we have to calculate the EA value. And here question what is given? K is equal to 4.5 10 power 11 per second E minus 28,000 K upon T. So this is given. Now here this is given in the form of A minus EA by RT. So we can compare this. This is A and E minus EA by RT. Now we have to compare this equation E minus EA by RT upon 28,000 by K by T. So here we compare this E minus EA by RT is equal to E minus 28,000 K upon T. This is given. Here we can write this EA by RT is equal to minus 28,000 upon T. Okay. So here minus minus cancel out and temperature is also cancel out. So what is remaining? EA by R is equal to 28,000 K now here we can write EA is equal to, moving this to right side, 28,000 K multiply by R. So EA is equal to 28,000 K multiply by R is gas constant, so 8.314 joule per Kelvin. So this Kelvin and this Kelvin cancel out, so that will become equal to EA is equal to, now here we can write this 28 multiply by 10 to the power 3 multiply by 8.314. Now this can be written as EA is equal to now EA is equal to what? 232.792. Here 10 to the power minus 10 to the power 3 is also written as joule kilojoule. So EA is equal to 232.792 kilojoule per mole. Here mole is also given as gas constant unit is joule per mole per Kelvin. So this is the answer. Now next question is, the rate constant for the first order decomposition of H2O2 is given by the following equation. Log K is equal to 14.34 minus 1.25 multiply by 10 power 4 K by T. Calculate EA for this reaction and at what temperature will its half period be? 256 minutes. So how to proceed this? First we correlate as previous question with Arrhenius equation, because it is written in the form of Arrhenius equation. So first we write what is Arrhenius. K is equal to AE minus EA by RT. Now we take log on both sides, so equation become log K is equal to log A minus EA by 2.303 RT. So here now we correlate with this equation, we get EA by 2.303 RT is equal to 1.25 multiply by 10 to the power 4 K by T. Now just as previous we correlate like this because it resembles from this equation. Now temperature cancel out and EA become 1.25 multiply by 10 to the power 4 multiply 2.303 into 8.314 joule per mole. Now after solving this will become EA is equal to 239.34 kilojoule per mole. So this is energy of activation. Now what we have to calculate the EA calculated and at what temperature will its half life period be? 256 minute, means T half is equal to 256 minute. So temperature will be what? Now for first order reaction K is equal to 0.693 upon T half. So here now putting the value we get K 256. Now here T half is given in minute inverse and the reaction is in first order. So here rate constant for first order reaction is in second, so we multiply it by 60 so that it will become second. So K is equal to 0.693 upon 256 multiply by 60 per second. So after calculating it will become K is equal to 4.51 multiply by 10 to the power minus 5 per second. Now next we correlate this k value in equation. This log k is equal to log a minus EA by 2.303 upon RT. We put the value here, k value. So equation is log k is equal to log a minus EA by 2.303 RT. Now here k value is 4.51, so we put this value in equation 1. Number this in equation 1. We get log k is equal to 14.34. Here a value is given 14.34 minus 1.25 multiply by 10 to the power 4 upon T per Kelvin. So here log k value is this 4.51 multiplied by 10 to the power minus 5 is equal to 14.34 minus 1.25 multiply by 10 to the power 4 upon T. Now we calculate this log 4.51 minus 5 log 10. It is written 14.34 1.25 upon T. Now log 4.51 value is 0.65 and here 5 log 10 means 5 because log 10 value is 1 is equal to 14.34 minus 1.25 multiply by 10 to the power 4 upon T. So here we now after subtracting this will become 1.25 multiply by 10 to the power 4 upon T is equal to 14.34 plus after solving this will become 4.35. Here this will become 1 point. Now after solving this will become 4.35. Moving towards right. Now T is equal to 1.25 multiply by 10 power 4 upon 18.69. So that will be equal to 668.8 Kelvin. Now the temperature will become 669 Kelvin approx. So this is how you will calculate this. Now moving towards the next question. Now the question says the decomposition of A into product has value of K as 4.5 multiplied by 10 to the power 3 per second at 10 degrees Celsius and energy of activation 60 kilojoule per mole. At what temperature would K be 1.5 multiplied by 10 to the power 4 per second? So here again the rate constant is in per second, so reaction is in first order reaction. Now how to proceed this? Power 4 per second. So as question implies that here Arrhenius equation is applied on this question with equation log K2 by K1 is equal to EA by 2.303 R 1 upon T1 minus 1 upon T2. This equation is applicable. Why? Because here you have to find out second temperature and first temperature is given. So and both rate constant value K2 and K1 is also given. So we put the value in it. Energy of activation is 60 kilojoule per mole. Now putting the value here, log K2 will be 1.5 multiplied by 10 to the power 4 upon 4.5 multiplied by 10 to the power 3 is equal to energy of activation is 60 kilojoule means 1000 upon 2.303. R is 8.314, that is gas constant, and here 1 by T1. T1 value is 10 degrees Celsius. Now we have to convert it into Kelvin. So we add 273 to 10 degrees Celsius, that will become 283. We always put temperature in equation in Kelvin. Now here we calculate this, and 283 comes from temperature 10 degree plus 273. To convert into Kelvin become 283 Kelvin. Now we calculate this. This will become log 10 by 3 is equal to 3133.63. Here we take LCM, that will become T2 minus 283 T2. Now here dividing this will become log 3.33 and here 3133.63. Now T2 minus 283.283 T2. Now log 3.33 value will become 0.5228 upon 3133.63 is equal to T2 minus 283 upon 283 T2. Now after calculating, this will become 0.000167 is equal to T2 minus 283 upon 283 T2. That comes to left side, that will become 0.0472 T2 is equal to T2 minus 283. 1 T2 minus 283. Now here we forgot here T2 minus 0.0472 T2. We forgot to write this T2. Now this will become equal to 0.9528 is equal to 283. So T2 will become equal to 283 upon 0.9528. Here T2 will become equal to 297.01. Now here we forgot here T2 minus 0.0472 T2. We forgot to write this T2. Now this will become equal to 0.9528 is equal to 283. So T2 will become equal to 283 upon 0.9528. Here T2 will become equal to 297.01. T2 is equal to 297 Kelvin. So in question you see that answer is in question, the temperature is given in degrees Celsius, so we should write answer in degrees Celsius. Just as question said, we have to write in that way. So this temperature is 297 Kelvin. So this temperature is 297 Kelvin. So this will become equal to, in degrees Celsius we convert this. So this is equal to T2 is equal to 297 minus 273 Kelvin. So T2 will become equal to 24 degrees Celsius. Now if you have any doubt regarding this 3 question, you can ask me in comment section. Do like and share with your friends. Keep learning and practice the question regularly.